All right, so the last time we talked about alkenes, right, and those are hydrocarbon compounds, organic compounds with one carbon-carbon double bond in them, right? Their general formula is CnH2n, where N represents the number of carbons, right? And so that's what ethene looks like as compared to ethane, which is an alkane which has all single bonds. Right, because it has a carbon-carbon double bond, it is a an unsaturated molecule because it has a double bond, right? Uh, we talked about the others in the series. So this is a homologous series, just like alkanes. And you start with ethene because you can't have a methene. You need a double bond, and so you need two carbons at least. And then you've got propene, butene, pentene, hexene. Now the book only goes up till butene, but there's no harm in going up till carbon number 6. Then we talked about how alkenes are sort of obtained, and that is through catalytic cracking. So you take longer and less useful alkanes and split that to make shorter alkanes and alkenes. So these are equations for depending on the reaction conditions, you can take the same alkane and break it up into different shorter alkanes and different alkenes. The reaction conditions are 550 degrees centigrade, and you have an aluminium and chromium oxide catalyst. Right? You can conduct the same thing in a laboratory. In that case, it's called thermal cracking, where the alkane, right, is heated and broken unglazed pottery is used as a catalyst. Now, what I'll focus on, well, start with today, not focus on, but what I'll start with today is talking about the different ways you can sort of represent or talk about these organic molecules, right? So one way is obviously the molecular formula. So you have the general formula for an alkene. For an alkane, it's CnH2n plus 2. And so when you write that out with the number of carbons and hydrogens, that is the molecular formula. Is like also similar for other molecules like HCl and NaOH, right, and Fe2O3, and right. So those are all molecular formula. So that's the molecular formula. And the displayed formula is when you draw it out in full, showing all the atoms and all the bonds, right? So the displayed formula of a molecule is a diagram that shows how various atoms are bonded and shows all the bonds in the molecule as individual lines. And if there's a double bond, we show two lines, right? So if you go back to alkanes, right, all of these, right, for methane and ethane and propane, butane, all of these are the displayed formula, right? And if you write it out like CH4, or in the case of propane, that's C3H8, right? So all of these are like the C3H8 part is the molecular formula, and when it's drawn out like this, these are all displayed formula. So right, that's two things. What I'll tell you today is right structural formula, and then we're going to talk about isomers. So structure, so right, molecular formula and displayed formula are clear to you guys. We talked about the last time. I reviewed it right now. Any questions about those?
No.
Okay. Now we have structural formula. And by definition that's given in the text, right, a structural formula of an organic compound right is an unambiguous description. Unambiguous description meaning that it is not confusing in any way, right? It is very clear description of the way the atoms are arranged. Where the atoms are arranged, including the functional group. Now, we haven't come across a very clear example, so to speak, of functional group. I mean, in the alkenes, double bond is the functional group, right? We've talked about that. So, right, alkanes don't have a functional group. So, right, the double bond is all we know for now. We'll come across some more functional groups in the next chapter when we talk about alcohols and carboxylic acids, right, and ethers. So, right, are arranged, including the functional group. Right now, so in the case of, right, let's take an alkane to be simple to begin with, right, and let's take propane. So you know propane is C3H8. We know, right, so that's the molecular formula. We know this is what propane looks like. So this is the displayed formula. Right, what is the structural formula? So for the structural formula, what you do, because it is describing the ways the atoms are arranged, and so what you do is you sort of break up each carbon and everything that's attached to it when you're writing. You don't need to draw this out, right? In this case, right, it's giving you, like, this is giving you the maximum information, the displayed formula. But for the structural formula, what you'll do is you'll write CH3, CH2, CH3. So does that coincide with the molecular formula? Yes, you've got 3 carbons, you've got 8 hydrogens, right? And it's also, in short form, it is telling you how the grouping is, right, how they're arranged. So first you've got 1 carbon with 3 hydrogens, then you've got 1 carbon with 2 hydrogens, and then you've got a carbon again with 3 hydrogens. And so that's giving you an unambiguous, and right, this is straightforward. So right, I'll give you some more examples where obviously, right, you have to be a bit more careful, but we're starting with the simple ones. So you have C3H8 displayed formula, molecular formula, and this guy is a structural formula. It is giving a description of the way the atoms are arranged. Does this make sense?
Yes.
Okay, so let's try pentane.
Can you explain that again?
We'll do this with example. Okay, so you got C5H12. I probably should have asked you the formula for pentane. Okay, fine. So, right, what is it going to look like? What's the displayed formula? Right, so this is the molecular formula. What the molecular formula tells you is, right, how many of each atoms there are. Obviously, there's like sort of a way of writing it, right? So, for example, Fe2O3, and you're going, well, I can write it as O3Fe2. Technically, yes, but that's not how it's written, and there's obviously right reason behind it. So you don't do that. And so, right, when you're using, like, when you're talking about hydrocarbons or organic compounds, you mention the carbons first, and then the hydrogens, and then if there are oxygens to follow, which we will have, and whatever comes later, right? So there's sort of like a pattern to it. Then you have the displayed formula, so you're going to draw out the whole thing showing each atom how it's arranged with all the bonds. And so this is a pentane, so it's all single bonds, 5 carbons, 1 2 3 4 5, right? You draw out the hydrogens. This is sort of the tedious part of it. Sobia, did you understand what a structural formula is? How you write it out? Do you understand that?
Uh, would you explain it again?
I'm actually going to ask you to tell me. Okay. So, right, this is the displayed formula. It's all drawn out, all the atoms, all the bonds, right? It's also showing its structure, what it looks like. So in this case, it's a straight chain. Very good. Now, what you need to do, just like over here, split it out. You just sort of change color over here to make it right. Split this. And so what do we have first? Aram, Sobia, what do we have first?
Uh, CH3,
CH3. Then
CH2. No,
CH.
okay, yeah,
Yeah,
CH2.
CH2. CH2.
And
CH2.
Again CH2.
Oh, CH2.
Okay, how many CH2s are we going to write? We've got CH3, CH2, CH2, CH2,
and then CH3.
CH3. And that is your structural formula. So what is it telling you? Right? It's telling you the way the atoms are arranged, right? So the first you've got, it's telling you you're starting off with one carbon attached to three hydrogens, and that means that automatically tells you that it has single bonds, right? And then it's telling you you've got one carbon with two hydrogens, and then same, and then same, and then you're ending with a carbon with three hydrogens. And so that tells you the order in which these atoms are showing up, sort of like in groups, like you technically loosely call them groups, right? Not scientifically, because that would mean something else, right? Just for your understanding. So, right,
Okay.
basically you're breaking up the molecule into pieces and writing it in pieces, right?
Yeah.
Along with its arrangement, like its sequence. So you're writing it in pieces, keeping in mind the arrangement and the sequence. I mean, you could say, oh well, I could write it out, for example, as why does this keep resetting? And right, you could say I could write it out as well. CH3 and then CH2 and then CH2 and then CH3 and then CH2. I still have five carbons and I have all the hydrogens, and we're like, yes, but right, it's not showing you the proper sequence. So if I want to draw that out, because right, the point is that all of these should make sense, they should coincide, right? So if I want to draw the displayed formula using this, it's going to match, right? But if I'm going to draw the displayed formula using this, so I'm going to have CH3 and then a CH2 and then another CH3. I'm like, okay, fine, I'm done, right? If I drew a CH3 over here, oh wait, no, that was a CH2. Okay, scribbling. CH2, CH3, and a CH2 over here. And okay, fine, I've got another CH2 and CH3. Okay, CH3. So I've got to and so well, I'm out of space because this carbon is now right. It has made all the four bonds it possibly can. And so where am I going to fit in this CH2? That means my structural formula was wrong,
Yeah.
because I cannot use it to make the proper displayed formula for pentene. Pentane, right? So this is not the structural formula for pentane. Does that make sense?
Yes.
Haram?
Yes.
Okay. And so you have to keep that in mind. Like, again, right? Unambiguous. should not be confusing. Description of the way atoms are arranged, right? So they're arranged in this sequence, right? And you look at it in pieces. Now, this was uh, for alkanes. Now let's take a look at alkenes, right? And so you have propene, right? What is the molecular formula for propene?
There are 6 carbons.
Pro is 3.
3 carbons.
Well, yes.
Mm,
And 6 hydrogens.
Okay, C3H6. Right, so propene is C3H6. So I'm going to draw 3 carbons over here. Now, where does the double bond go?
mm,
Between
well,
the first
one
two
on
carbons.
either end.
One on either end, so like this.
No, no. Um,
No.
wait.
In this case, it doesn't really matter because there are just 3. Just put it to start with. Like, you just pick a side. Either you begin with it or you end with it.
Begin with it. Okay.
Okay? And then you obviously fit in the hydrogens. Right now, in this case, you sort of try to make the molecule symmetrical, and so you don't want a hydrogen over here, you want it top and bottom. And so this
Yeah.
carbon has 4 bonds. Then, right, obviously there's going to be a single bond between these 2 carbons, and so this guy only gets 1 hydrogen, right? And then this guy gets 3. So this is the displayed formula. Does it look fine?
Yeah.
Okay.
Okay.
Okay. Now, what is the structure formula going to look like for this guy? Can you tell me? Again,
CH2.
CH2,
CH,
CH,
CH3.
CH3. Now, the only thing you need to be, look out over here is because there's a double bond and it's a structural formula which again is telling you the way the atoms are arranged and it's supposed to be unambiguous. Right, I can sort of figure that out if I use this to make it. I'm like, oh, so the first carbon has 2, the second has 1, and so when I'm trying to fill out the covalent bonds that I'm making, right, I sort of get an idea. But just to be, because it's supposed to be unambiguous, what I'm going to do in this case, because there is a double bond, I'm going to show it. Does that make sense? Right,
Yeah.
I'm going to show that, oh, the double bond in propene is between the first and second carbon. Does that make sense?
Yeah.
Yes.
Okay. Let's quickly try another. Right. Let's try. Right. Yeah.
Ethanol.
Ethanol. Where did ethanol come from?
We can try that. Can't we?
I mean, we could. We haven't formally talked about. Uh, you know.
Okay. Yeah.
Okay. Let's do ethanol. Right. Do you know what the formula for ethanol is?
There are two.
God. One
There are
carbon.
2 carbons.
Yes. And
4 hydrogen.
no, there are 5 of them.
Okay, sorry.
And
Haram, you answer.
you're asking me to do something we haven't studied yet.
Okay, then let's do another one besides.
Yes. Okay, let's do hexene. That's how many carbons?
6.
How many hydrogens?
12 or
12.
14.
And don't do the or part, right? It's an alkene, so it's CnH2n. Okay, drawing out the displayed formula. Oh god. 1, 2, 3, 4, 5, 6. Where does the double bond go? At the start or at the end?
Yes. At the start.
At the start, right? And so the rest have single bonds, and then you fill out the hydrogens. Right. And then you look at it in pieces. So, what is the structural formula going to be?
CH2 and double with a double sign.
Double bond.
Yeah, double one
Okay.
and CH.
Yeah.
Haram, would you like to go or should I continue?
You should.
CH2 and another CH2 and another CH2
Mm-hmm.
and then CH3.
So that would be the structural formula for hexene.
Okay.
Does this make sense?
Yes.
Okay, now just to tell you, if you want to be very particular with the structural formula, what you could do is you could do CH2 double bond CH. You could put a single bond to show that the bond between this carbon is a single bond. Similarly, over here you could do CH2
Yeah, I was wondering why he didn't put a single one on that.
because the rest, like if you're not putting anything that like sort of automatically says that there's a single bond, right? Because the single bond is sort of like the go-to.
It's known.
Yeah,
Okay. So
right.
there's no need to put a sign on it, right?
Matlab in the structural formula, yeah, no, not over here, like it,
No, not talking about that.
right?
Okay.
So you can put. I think I sort of like. Yeah, I need to rewrite this. And so, right, if you're not putting the sign of a bond, that automatically means there's a single bond, right? So if there's a double or triple bond, then that is something you need to highlight. But if you want, you can write it this way. So CH2, 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 and then CH3. So you are sort of making it even more unambiguous that, oh, there are single bonds between all of these guys. Okay. Now let's do something a bit more fun, right? Let's talk about structural isomers. So what is an isomer? In fact, let me write out the full thing: structural isomer. You guys still there? Structural isomers. A structural isomer They are compounds with the same molecular formula but different structural and displayed formulae. Right? Now, how does this make sense? For this, let's take a look at butane. So butane is how many carbons?
4.
How many hydrogens?
16?
8.
No, wait. Sorry, 8, yeah.
No, it's a butane.
Yeah.
CnH2n
10.
plus 2. So that's 10. Right? And again, right, the structural formula is like this. I'm not drawing the hydrogens. And the displayed formula, and the structural formula is CH3 CH2 CH2 CH3. Now, what if we have another molecule that has a molecular formula of C4H10, and this is what it looks like. Count the number of carbons and hydrogens, please.
Okay. 10 hydrogen.
So we've got
And 4 carbons.
we've got 4 carbons and 10 hydrogens, right?
Yeah.
And so that is obviously, not butane. I mean, no, sorry, the molecular formula is butane. It's similar to butane, but when we see the displayed formula, you're like, okay, that does not look like butane, does it?
Yeah.
Okay. Now, what is this? Right? This is called an isomer. Why? Because, and a structural isomer to be specific, right? Why? Because the structure of the compound has changed. Instead of having a straight chain, what you have now is a branched chain, right? So this is called a branch, right? It's sticking out, right? It's not like, basically it's not forming a straight chain. So you've got one or two carbons or more than that attached somewhere else as compared to the regular structure. Okay, so this is what a structural isomer is. It has the same molecular formula, so you have the same number of atoms in total, right? The displayed formula is different. Why? Because it looks different, right? So this is actually a different compound. It's not butane, it's a different compound, right? Now, what is this compound? First of all, what do I name it? And then how do I write down the structural formula for this
It does
compound?
look like a diamond. Like the shape of it. Yeah.
Yeah, but you should know that diamond is like pure carbon structure.
Yeah.
Yeah.
Okay.
Okay. So what you do, right, is first of all, now this one's easy, right? First of all, what you do is you look at the longest straight chain possible, right? So this is like you got total 4 carbons, right? You can either look at it, oh, 1, 2, and 3. This is the longest chain I'm getting if I look at it this way. Again, I go left to right or right to left, is the same thing, right? Or if I go 1, 2, 3. So the longest chain I'm getting is 3 carbons. Now I need you to pay attention over here. All right.
Yeah.
So this is the longest chain I'm getting. Okay. Right. So what kind, how do we name an organic compound that has 3 carbons in it?
Could you repeat that?
How do we name an organic compound that has 3 carbons in it?
Propane.
Okay, so now we know, right? We're going to base our name off of that, right? So the longest chain we have is of 3 carbons, so it has something to do with propane. And why propane? Because they're all single bonds. I don't have any double bonds over here. Okay,
Yeah.
then
But how do we know it's an alkane? Oh, okay, got it.
single bonds, right? Because it has no other particular functional group. Right? There's no double bond, there's no OH, there's no C double bond, C double OH for carboxylic acids, none of that. Okay. Now, so if this is how I'm numbering it. So I want to look at the longest. In any case, right, this is the longest chain I'm getting, 3 carbons. Okay. Then what do I do with this guy? Right? So because this is a side chain or a branch chain, right? This is like a side or branch chain. Now you'd say, well, that's not a chain, it's just a single carbon. Yes, but that's what it's called, right? You could call it a side group or a branch group if you're like, right? How many carbons does this guy have? Hmm?
1 carbon?
And so what do we name an organic compound that has 1 carbon? Right? The name will obviously start with meth,
Hmm.
right? This name will start like this is something to do with propane. It's going to have prop in it. Okay, so we got that. Now, how do we name this? So what we do is we start with the position of the side group, right, in the naming. Now, how do we know the position of the side group? We name it using the number of the carbon that it is attached to. So in our numbering, this side group or side chain is attached to carbon number 2.
Yeah.
Yes,
Mm-hmm.
Haram?
Yeah.
Okay. So we're going to start with 2, and this dash is not like it's not showing a bond. Okay, it's just hyphen grammatically, right? And then we name the side group. And in this case, because the side group is CH3, so it is methyl. And then the main chain, the longest chain is 3 carbons, 2-methyl propane. So the base compound, the main compound is a propane molecule, and it has a methyl group attached to carbon number 2. On that note, right, if you have compounds like these, groups like these or molecules like these, this is how you name them: methyl, ethyl, propyl, butyl, right? So that's 1 carbon, 2 carbon, 3 carbon, and 4 carbon. You probably might not need to go as high as that, but right, for example, they were like, if there was a side chain in a molecule that was like 4 carbons long, instead of methyl, you would say butyl. Just saying, right? So just
Yeah.
telling you how the naming works. So, right, the longest chain is 3 carbons, so that's a propane, and then you add the name of the side group before it, and then the position. So the methyl group is on carbon number 2 of the propane molecule. So the whole thing becomes 2-methyl propane. Is this
Okay.
making some sense?
Yeah.
No.
No. Okay. Now, as per the structural formula, right, how do you write the structural formula? So what you do is you obviously, like I said, break it into pieces. Now, when you're breaking it into pieces, sorry, I broke that into incorrect pieces. Right? So this is one piece. This is the second piece. And this is the third piece. So how do I write this down? The first piece is CH3. The second piece is actually a CH. So I write a CH. And because the side group is bonded to the second carbon, which is the CH part, I write the side group in brackets. And then I write the third part in this case, which is CH3. So first part over here, second part with the side group in brackets, and the third part. And that is my structural formula for 2-methyl propane. Okay, obviously this doesn't make as much like it's the first time you're doing this. Let's try another. Right, for an alkane to keep it simple. Let's try something like we tried 4 carbon, right? So let's try something with 6 carbons. So, right, what's the formula of an alkane with 6 carbons?
Six carbons and
12.
12 hydrogen.
Alkane
10.
40.
14. Sophia, what are you up to? You're giving me random numbers.
Sorry.
14. Now I'm not going to draw out hexane because we did that earlier, right, over here. So this is what hexane, well, so that's a hexene, but anyway, right, hexane, I'm not drawing out hexane itself. What I am drawing out, okay, you have 1, 2, 3, 4, 5, 6. Now, what's the longest chain you can, like, and you've got all the hydrogens over here, so I'm not being particular about.
The third one.
Huh?
The third.
I'm sorry, your voice is breaking up.
The third one.
First of all, identify what's the longest chain you can get. How many carbons can you get in the longest chain? Okay, 3?
Yeah.
How? How 3?
Like horizontally, it would be like,
No, you start from one end and go to the other now. So if I count it this way, 1, 2, 3, 4. I'm getting 4 carbons. Okay, fine. Right? What if I count it this way? 1, 2, 3, 4, 5. Oh, I'm getting more carbons. So I'm saying longest chain, longest continuous chain, right? Even like remember one thing, right? If I draw pentane like this, or if I draw it like this, is there any difference between these two guys?
no.
No,
No.
no, right? Because it's a continuous chain. No one said there's supposed to be like a straight chain, right? I can like draw it bent down. Now, normally I wouldn't do that, but the point to make clear is even if I'm drawing a bend, right? It's a continuous chain. So what you're looking for is the longest continuous chain. Okay.
Yeah.
So in this case, I'm getting 5. Okay. I can try something else as well. I can start from the other end, right? So that's something I have to check. Okay, let's start from the other end. 1, 2, 3, 4. It's still giving me 4. Okay, 1, 2, 3, 4. This is also giving me 4. So the right longest I'm getting is 5. 1, 2, 3, 4, 5. Oh, by the way, is it making a difference if I start from here? 1, 2, 3, 4, 5. Same thing, obviously, right?
Yeah.
So the longest chain I have is 5 carbons. What name would I give to an alkane? And I'm saying alkane because they're all single bonds. What is the name I would give to an alkane with 5 carbons?
Hexane.
Hexane. Hexane is 6. What's with 5?
Pentene, I guess.
Pentane. So I know that the main compound I have over here is a pentane molecule, right? It has 5 carbons, right? What is this group? Right, this is what we have as a side group, right? How many carbons does this have?
1.
1, right? So what name would we
One.
give to it?
Methane.
Not methane.
Methane.
Methyl. Methyl, right? And which carbon is the methyl group attached to?
Pentane.
Which carbon number?
1.
Sobia, are you
Yeah.
okay? I've put the numbers against the carbons. Which carbon number is
5.
Sobia? What number is
Three.
this?
3.
3.
Yeah. Okay.
Right, so how do we name this? This is a pentane. It has a methyl group attached to it. Which carbon is attached to? 3. And so this molecule is 3-methyl pentane. Does that help in your understanding a bit?
Yes.
Okay. Now, right, why do isomers matter? They matter because isomers have different properties. So for example, over here between butane and 2-methyl propane, the book mentions that the melting point for butane is minus 138 degrees centigrade, whereas the melting point for 2-methyl propane is 159 degrees centigrade. The boiling point for butane is 0 degrees centigrade, whereas the boiling point for 2-methyl propane is minus 12. Right? So, right, isomerism or isomers have different properties. Oh, and we are missing the structural formula for this guy. Right? So, what is the structural formula? Come on, guys.
C3.
CH3,
CH2.
CH2.
3C.
First, you write CH because this carbon has only one hydrogen attached to it over here. Sort of got overshadowed by the circle I drew over it. Okay, overwritten, sorry, not overshadowed. So CH, and then right, the side group, because the side group is attached to the third carbon. So remember, right, the structural formula needs to be an unambiguous description of the way the atoms are arranged. And so you need to make clear in your structural formula that, oh, the side group is attached to the third carbon. And so first of all, you're drawing the main, so the CH, then you're putting brackets, CH3. Okay, so that's the side group. Then what do you have?
C3,
No,
CH3,
no, it's not CH3. What is
CH2,
this guy? CH2, and then
And then another CH3.
CH3. Okay. So how many carbons do we have? 1, 2, 3, 4. You've got 6 carbons. You've got 14 hydrogens. You can count them up. And again, right, why does this need to be accurate? Because I should be able to draw this displayed formula using the structural formula.
Okay.
Right, so when I read this, and then, okay, fine. First comes CH3, then CH2, then there's a CH with a side group, and then a CH2. And by the way, right, I can draw this molecule like this as well. Just this last thing, because, right, I have another class, and right, I actually intended on going over this much quicker, but obviously it took time, which is fine. So I can draw it like this. Right, this is the straight chain of 5 carbons. I can also draw it like this. It's the same thing. Again, I told you, right? Longest chain for 5 carbons. You've got this guy as a side group on the third carbon. These two are exactly the same thing. Just because I drew this out straight with the side group over here as compared to, right, doesn't change the fact that it's the same thing. The displayed formula is the same in both cases.
Okay.
Okay, so you guys probably need some time to, mentally digest this. So you obviously have until tomorrow. We will make progress tomorrow. Obviously, make progress today, but going to go further tomorrow. Talk about alkenes further. Hopefully, finish up the chapter. And so yeah, all right. So do review this. Do take a look at the text. If that helps you make more sense of it. I'll actually share. I'll share a link with you guys. I had a video prepared, but the explanation took more time. The video is like 5 minutes long, but as I said, like I actually have another class right now, so I can't spend 5 more minutes. Maybe at the beginning of tomorrow's class, right? I'll just show that, and so hopefully that will help in your understanding a bit better. Okay.
Okay.
All right. See you guys next time, inshallah.
Inshallah. Okay, Allah Hafiz.
Allah Hafiz.